So part 2 of this video, we're going to start looking at some of these trial and error examples. We're actually going to go back to the perfect square idea and see how this relates to the trial and error and the foiling. Now remember that middle term was always outside plus inside. And if you look at the difference of perfect squares, there's no m term in the middle. There's not a third term. Well, why is that? What happens, let's go back to the rule. The rule for perfect squares says a squared minus b squared will always factor into a plus b times a minus b. And so the square root of 16m squared is 4m. The square root of 10, or 100 is 10, and 4m plus 10. Now if we think about foiling this and checking my outside and my inside, I end up with negative 40m, and I end up with positive 40m, which is 0. And that's why it works to do the opposite signs. Now, in fact, I could have taken a greatest common factor out of this first, but it doesn't matter. Let me get the 4m minus 10 times 4m plus 10. It's okay, I forgot. I can pull a greatest common factor of 2 out of this one. And I can pull a greatest common factor of 2 out of this one. Regroup my my constants, and still get where I'm supposed to be going. I just recognized those perfect squares instantly and went ahead and grabbed them first. Now, let's go down to 18 minus 50n squared. There is a greatest common factor here, so I'm going to take that out. That's a 2. And I have 9 minus 25n squared. That leaves me a perfect square in the middle. If you wanted to try to do it by trial and error, minus, you get kind of stuck because what's in the middle? So if you wanted to think about plus 0n in the middle, you see that it's one of each, which factors of 9 and 25 are going to combine to make zeros. It's way more complicated than it needs to be. So we say 3 and 3, 5n and 5n, and when we check, that middle term drops out. And so this is the answer. Now what happens with positives is if we write it out like this, with that 0 in the middle, and you think about trying to put plus plus in a way so that when you combine the outside and the inside, and the outside and the inside, you get 0. It's pretty quick to see that you can't add two numbers together that are both positive and come up with 0. It always has to be an opposite sign situation to make 0m, 0n in the middle. So that's why we cannot factor the sum of perfect squares. So let's start looking at some examples like this. These first two examples are ones you've seen before. These are the ones you did in Math 2. There's no number in front of the x, and so we have two factors. There's an x in each one. This happens to have a y, so we just drop a y into the back. I have minus plus, which means minus, minus, and I have the factors of 8 that are somehow going to make 9. So I'm going to list them, 1 and 8, 2 and 4. Now those two factors have to go right there by the y, and they have to go there in such a way that when I multiply them times x, I get negative 9. So if I start by putting 2 and 4 in there, and if I put a 2 in here and I put a 4 in here, I still have 8 in the back, but in the middle I have negative 2xy and negative 4xy, which is negative 6xy, which is not what I want. So I erase those. And then I try 1 and 8. And when I test that, I get negative 1yx minus 8yx, which gives me negative 9yx. Yx, xy, same difference, which is what I need. And so my factored pairs are x minus y and x minus 8y. If you FOIL them, you will get your original back. If we look at another example that's just like that one, A is all alone. So we have A in the first position. We have minus, plus, minus, minus. Now we've got a B in the back position, so I'm going to drop that in. Now we have the factors of 10, 1 and 10, 2 and 5, that we have to add together so that they equal negative 7. Well, 1 plus 10 is 11, and 2 plus 5 is 7. And so if I put a 2 in here and a 5 in there, and I check my outside term, minus 5ab, and my inside term, minus 2ab, I get negative 7ab. So my factored form is a minus 2b times a minus 5b. And those are the two numbers that were multiplied together to form that trinomial. Now we're going to go into the new stuff. Sometimes you'll have a coefficient, that means a number, in front of your first variable. And then you have to start taking into account how that number affects those outside and inside terms. So we always look for greatest common factor first. There isn't any between 7, 20, and 12. So I'm still going to start with my two sets of variables. I'm going to put a k in each one, and plus plus means my factors are plus plus. Now, I still am trying to figure out what number is going to go in each of these positions so that my outside and my inside multiply together and then add together to make 20k. But instead of only looking at the factors of 12, I now have to also consider how the factors of 7 impact this. So I'm going to say 1 times 7, those are my factors of 7, and I have 1 times 12, 2 times 6, and 3 times 4 as my factors of 12. Those are all the possibilities. Now I have to systematically go through putting them in and testing my middle number. Now I could do it here. I could put 1 in here and 7 in here and then try 1 and 12. And that would make 7k and 12k, which is not 20k. But instead of overly messing up my picture, I'm going to do it off to the side. And that is how I can keep my picture a little neater when I'm drawing. So I'm going to start, and I'm going to say 1 times 1 plus 7 times 12. So that's taking this factor and this factor times each other, and this one and this one. Remember, outside and inside is 1 of each. That's not 20. I have to flip it. I have to take 1 times 12 and test that combination with 7 times 1. That's not 20, so I've exhausted 1 and 12 as my possibilities. Now I'm going to take 1 times 2 plus 7 times 6. That isn't 20. Now I'm going to flip it and try 1 times 6 plus 2 times 7. That is going to be 20. So those two are my factors that are going to make 20. All right. So part of the reason why I like to list it this way is it also helps me get it into my picture correctly. These factors of 7 have to go with the k because they need to be the first ones when I FOIL to go back to my original. So if I put the 7 here, this line tells me that the 2, which is a factor of the 12, has to be in the back position because those two are the two that need to get multiplied together to make 14k. Then my factor of k is 1. It has to get multiplied to 6 so that my inside terms are 6k, and together I make 20k like I want. So my factored version is 7k plus 6 times k plus 2. Now, if you FOIL it, watch what happens. First two terms, 7k squared. Outside terms, 14k. Inside terms, 6k. Last terms, add these two together, 7k squared plus 20k plus 12 is exactly what, oops, I missed, we started with. All right, let's look at another example. Now 3a squared minus 24ab minus 60b squared has a common factor of 3. So I'm going to take a common factor of 3 out. And when I do that, it reduces to my familiar set with no coefficient in front of the a. So now I'm going to have my two factors minus minus. It's one of each. I drop an a into each position. I drop a b into the back of each position. And now I have to think about the factors of 20 that when I, in essence, subtract this time, because I'm going to have one positive and one negative, make negative 8. So 1 minus 20 is 19. 2 minus 10 is 8. If I want the 8 to be negative, I want the 10 to be negative, and that means the 2 has to go there. So my fully factored form is a plus 2b times a minus 10b. And again, if you